And, pardon me, I'm sitting on my pen. Accidentally pressed stop recording, and that's disastrous. But it'll be all right. So this is going to be 4/3 of t to the third. T to the third, when t is 3, is going to be 27. So a third of it's 9. 4 9s is 36. 36 plus 9 halves minus 4/3 plus a half. Maybe I'd have been better leaving this as 4t plus t. It's going to be all right, though. Okay, so 9 halves minus a half is 8 halves. So 36 and 4 is 40. 40 minus 4/3. 40 minus 4/3 is 1/16 over 3. Yeah, that's not going to divide evenly, because 6 plus 1 plus 1 is not divisible by 3. And I'll need a slope. D prime is going to be, when I plug in 1 for x, I'll get 4 times 9, because that'll be 3 squared, plus 3, minus 4x squared is 4 times 1, plus 1. All right, so I've got 36, and 3 is 39, minus 5 is 34, so y minus 1/16 divided by 3 is 34 times x minus 1. Yeah, I probably should have left that problem the way it was, but I definitely didn't originally intend for it to be 4t plus t, but I don't know. Okay, that's a tangent line. Let's see. It said to do that for which ones? D. Okay, we're skipping E and going straight to F. Okay, F is a constantly zero function, as I was saying, so the tangent line is going to be y equals 0. That would not be very interesting to do. Okay, that would be if I had gone from, I don't know, that and negative x to 2x or something, then it would have been more interesting. But as it is, it's a constantly zero function, so it's going to have a constantly zero derivative, and the tangent line would be y equals 0, because that is the graph. Now we're going to do the same thing for function g. And that's going to be, okay, you get a point, plug in 1 into g, and so that'll be the integral from 2 to 1 of t to the negative 3 dt. And I might do that up above. Okay, find an antiderivative by adding 1 to the power and dividing by that new power and letting that run from 2 to 1. All right. And then this will be, I might factor out the negative half. Any power of 1 is 1, minus 2 to the negative 2 is 1 over 2 squared. Okay, so I've got 3/4 times negative half is feeling like negative 3/8. Right? And I've got my point, get my slope from plugging 1 into 2x to the negative 5. Well, that's going to be 2 times 1 to the negative 5, and any power of 1 is 1, so that's going to be 2. Right. And so now I've got a point and a slope. I can write my equation. So y minus negative 3/8 equals 2 times x minus 1. Right, is h on the list? No, we're skipping that one. And j, we're going straight to k. So I have n here, there's k. All right, so, all right, getting a point by plugging in x equals 1 into k. So 1 and the integral from 1 to 1, O of t dt, that's going to be 0. And the slope, get from plugging 3 times x to the 5 minus 2 times x to the 3 is going to be 3 minus 2 will be 1. And I'll get y minus 0 equals 1 times x minus 1. Or y equals x minus 1. Asking for k and n. Right, so swap that out. And they'll work up here. Okay, yeah, the point is going to be the integral from 0 to 1 of 1 over 1 plus t squared dt. We need to know that an antiderivative for this is inverse tangent of t. This t runs from 0 to 1. Inverse tangent of 1, okay, think to yourself, where is tangent equal to 1? Where sine is equal to cosine? That's going to be there at pi over 4, where these two are the same. Okay, so it'll be pi over 4, and then you also think where is tangent most obviously equal to 0 along that kind of place, and that would be right here, where y was 0, right? 'Cause sine is 0, tangent sine over cosine. I get that, and that's pi over 4. The slope is going to be 1 over 1 plus x to the 6 times 3x squared. Okay, no, it's this. Is 3 times 1 over 1 plus 1 is going to be 3/2. My point is going to be 1 in pi over 4. Didn't actually say that, but so my equation, I've just well and truly run out of room. Let's just cover that up. My point is x is 1 and y is pi over 4. So my equation is going to be y minus pi over 4 equals 3/2 of x minus 1. Right. That's all the ones that did not require the use of a calculator. Now A, E, and J will require the use of a calculator, so I'm going to go back to this one. And pretty much, maybe I'll switch color up here. For A, my point is going to be x is 1 still, right? Yeah. And y is, well, not really sure why. Did I copy it wrong? Nope. Y is going to be 0 because when I plug in 1 for x there, I'm going to take the integral from 1 to 1, so I don't know what I would need the slope for. Maybe for the, or what I would need the calculators for. Maybe I need the calculator for the slope. Right, now to get the slope, I'm going to have that be e to the 2 times the sine of 1 to the 1/2 power. So maybe I'll just call that the square root of sine of 1, and as soon as I hit that sine button, I know I need to be checking to make sure I'm in radian mode, and I get 6.778. So my equation is y minus 0 equals 6.778 times x minus 1. It's A, E, and J. Here's E. Right here. Alright, and so this one, I'm going to get a point by letting x be 1 and y is the integral from 0 to 1 of sine of t squared dt. Okay? There is no closed form antiderivative for sine of t squared with respect to t. So that's something we have to compute using a calculator. So we're going to integrate from 0 up to 1 sine of x squared dx. We'll get 0.310. Slope is going to be sine of 1 times 3. So 3 sine of 1 is going to be 2.524. The equation is going to be y minus 0.310 is 2524 times x minus 1. A, E, and J. Here's J, it's down here. That's H. There we go. That's J. Alright, now to get a point, I'm going to have to plug in x equals 1 and plug in x equals 1 there. Integral from 3 to 0 of t cosine t dt. Now this is the type of integral that we will be able to run later on in the course. We'll get a kind of a product rule for integrating by parts, but for now we don't know how to do that. Okay. If this was t cosine t squared, we could use a substitution, but that's not what we have. So I'm going to integrate from 3 to 0 t cosine t, whoops, dt, call that 1.567. the slope here is going to be -3 times the cosine of 3. Okay. 2.969 or 2.970, whichever one you want. And so my equation will be y minus 1.567 equals 2.970 times x minus 1. Okay. And that solves the tangent line equationing that I'm going to need to do for now. So I'll get rid of all of these and get to moving forward. Let's see what we got here. The graph of y equals f of x is shown on the right. Let g of x equal the integral from 1 to x of f of t dt. Okay. On these, first thing you want to do is take the derivative. Okay, so g prime of x equals, take the x, throw it in wherever you see t in the integrand, and multiply by the derivative of x, that's just 1, so that's just going to be f of x. Find the intervals on which g of x is decreasing. Well, that's g prime of x is less than 0. That happens to be when f of x is less than 0, since they're equal. And f of x is less than 0 from 2 to 6. Okay. Write an equation for the line tangent to the graph of g at the point where x is equal to 5. I'll write a point. Or maybe I'll do the slope first, because that'll be the easy part. The slope is going to be g prime of 5 equals f of 5, and then I go over here and f of 5 equals -1. To get the point, I'm going to need g of 5 equals the integral from 1 to 5 of f of t dt. So the amount of area under the graph, okay, so from 1 to 2 I've got a half, but then I got a -1/2, so it's really just this. It's 1, 2, 3, and it's negative. If you wanted to run, I don't know, that trapezoid, or is that even a trapezoid? It's some kind of quadrangle. Negative that plus the half would be my guess. But I'm just looking at these areas balancing out, and then I'm just left counting this, which was 1, 2, 3 in the negative direction. So now my equation is y minus -1 equals -3 times x minus 5. Does the line I just wrote sit above or below the graph of g, and why? Okay, we know that that has to do with the curvature of the function. So I need to be considering, is g double prime positive or negative at 5? G double prime of 5 equals, well, I don't really have anything for g double prime yet, but I could take the derivative of both sides of that equation and say that's going to be g double prime equals f prime. And so that's going to be f prime of 5 at x equals 5, the slope of this is 1, which is a positive number. Okay. And if the function is decreasing while concave up, its tangent line will be right there, and because it's concave up, the tangent will sit below. So, but this is the reason why. So I'm going to say because the second derivative is positive, that means the tangent sits below the graph of g. Right. The graph of y equals h of x is shown. Let f be the integral from 0 to x of h of t dt. Find the intervals on which the graph of f is concave up. So the first thing I'm going to do over here is I'm going to take the derivative of f. F prime of x equals h of x. I can take the second derivative. That'll be h prime of x. Okay, and f is concave up, means f prime is increasing, means f double prime is positive. So f double prime is greater than 0. That happens only when h prime of x is greater than 0, and so I'm looking for where the graph of h is increasing. Right? And from here, it's decreasing. It's got a sharp corner, and it continues to decrease. But then after here, I'm increasing. So this is where x is greater than 0. You find f of negative 2, f prime of 2, and f double prime at 3. Okay. Okay, I see where this is going. F of negative 2 equals the integral from 0 to negative 2 of h of t dt. Okay. 0 to negative 2 that's the opposite of the integral from negative 2 to 0, which is what I would get if I was integrating forwards, right? Forwards. And what else was I going to say about that? Oh, yeah, and then this is something that I'm going to find using geometry. Okay, so this is going to be the amount of area in this quarter circle, so it's 1/4 pi times radius is 2 squared, so that's pi, but it's negative pi because it's under the x-axis. Okay, so the negative pi is that integral that I've boxed off there, which is negative because the graph of h is below the x-axis. This negative is because of, reversing the bounds of integration to go from lesser t-value to greater t-value. All right, so that's f of negative 2 equals pi. F prime of 2 equals, you can't see it anymore, but that's going to be h of 2. And h of 2 is going to be 0. Okay, so although there is a sharp corner on the graph of h, wait, no, yeah, that's the graph of h. This is the derivative. And if the derivative exists, like if there's graph here, then that means the derivative of f exists, even if there's a sharp corner. What won't exist is f double prime of 2, or h prime of 2. That's what isn't going to exist. F double prime of 3 is going to be the slope of h at 3 because of that. Okay, the slope of h at x equals 3 is right here. So this is 2, 0. So it's rising 2 when it runs by 3, so that slope is 2/3. Alright, suppose f of x is the integral from 14 to x squared of t minus 100 dt. Where is f of x decreasing? Okay, well, I need to take f prime of x. Maybe I'll switch up the color a little bit. Well, in order to find where it's decreasing, I need this derivative. So f prime of x is going to be where I take that x squared and throw it in wherever I see t in the integrand. But since it's not just x, I'm going to need to multiply by the derivative of that. So it's going to be a plus times 2x. And if I want to know where it's decreasing, I'm going to want to make a sign chart or a sketch of the graph. This looks like polynomial, so I'm probably going to want to sketch the graph. Okay, 2x, x plus 10, x minus 10. Okay. This is a third-degree polynomial with a positive leading coefficient. I got 2x, 1x, 1x. Okay, so I know it's going to come up through there, down through here, up through there like that. And decreasing is where, this is a sketch of f prime. Decreasing is where f prime is negative. So it's going to be all through here. So that's where x is less than negative 10, or where 0 is less than x is less than positive 10. And that's where f is decreasing. Page one time. All right. Graph of y equals f of x is shown below. G is the integral from 0 to x of f of t dt. On what intervals is g positive and decreasing? This one, I know this one. This is related to a multiple choice question that has been historically difficult for my students. Okay, so g is increasing. Let's start with that. G prime of x equals f of x. Okay, so g is increasing when f of x is greater than 0. So that's from -1 to negative infinity to -1. This is where x is less than -1. But g is positive. Okay, g is never positive for positive x values, right? We can see right here that I'm adding negative area. If you think of g as an area counting function of f. Okay. Over here, as I go to the right, it's just counting negative areas because I'm underneath the x-axis. So g is never positive over here. And over here, it's going to be negative because it's going to be positive because I'm subtracting a negative area. Okay. And then all the way up until here, okay, so right, I'm adding, or really I'm backwards integrating on a negative region, which is adding up area, right? So I'm positive. Here I've got a maximum also, because this is the picture of the graph of g prime, right? You can see that there's a relative maximum there. Okay. All the way up until here, I'll be decreasing because I'm backwards integrating on a positive region, so it's like my function is getting smaller. And I say decreasing, I mean as I move to the left. So really it's increasing as we move to the right. So as we said, anytime x is less than -1, the function's increasing. So what I'm saying is that all the way up until -2, the function is positive. So g of x is greater than 0 for x in the interval -2 to 0. Okay. But over here, g is decreasing because g prime, which is the picture of, which is the graph I'm looking at, it's negative. Okay. So it's increasing and positive over here, where it's positive but still increasing towards that maximum. So -2 to -1. Maybe you weren't satisfied with. I feel like this is one of those situations where I'm thinking that's not going to be enough. People are going to ask me about it tomorrow. So I'm going to hold on to that for now. I'm going to grab a Post-it note and do something else. Okay. I don't have anything else to say about where it's increasing. But what I will say is that g of 0 equals the integral from 0 to 0 of f, and that's 0. Okay. G of a positive number equals the integral from 0 to a positive number of f of t dt. But since f is negative, that's going to be negative. Okay. G of -1 equals the integral from 0 to -1 of f. Okay. And that's the negative of the integral from -1 to 0 of f. Okay, that integral would be, it has a width of 1 and a height of, it looks like 3. So that would be -3/2 would be that. But it's the negative of -3/2, which is positive. Okay, so yeah. Okay, so it's still positive there. G of -2 is equal to the integral from 0 to -2 of f of t dt, which is the negative of the integral from -2 to 0 of f. And what's happening here is that, well, from -2 to 0, I've got this triangle here and the identical triangle like kind of mirrored over there. And so they're going to balance each other out. And I'm going to say that's 0. Okay? And since I know that g is increasing when x is less than -1, I know it's going from 0 here to increasing until it hits that maximum. But then it's decreasing afterwards, and so that's another reason why it's -2 to -1. All right. Let g be this function. Where is g decreasing? G prime is x to the 3 minus x squared minus 6x divided by the square root of x squared plus 7 times 1 for the chain rule, because it's just x up there. Okay, and I need to know where this is negative. Well, the thing is, this is always positive. Right? Because you take a number, you square it, you add 7, that's a positive number, you take the positive square root, you get yourself a positive number. So what I'm going to do is I'm going to factor the numerator. Yeah, I'm not sure what that was. And I'm going to factor out an x and be left with an x squared minus x minus 6, which is an x times an x minus 3, x plus 2. I do know what that is. That's the air conditioner, and I don't know what's going on. It does not sound good. Okay, so I'm going to make myself a sign chart, and 0, -2, and 3, pardon me, thought I was still in my shot. And I'm going to choose a really negative number, like more negative than -2, and all 3 of these things will be negative. If I choose like -10, then 3 negatives makes negative. -2 to 0, try -1. Negative, negative, positive. Okay, 2 negatives makes positive, so this is positive. Between 0 and 3, I'm going to try x equals 1. 1 times -2 times 3 is going to be a negative number. And then something bigger than 3, like 100, all of these will be positive. Okay, so I want g decreasing, that's here and there. So this is -infinity up to -2, also 0 to 3. Suppose g is a continuously differentiable function with g of 2 equals 5, g prime of 2 equals 3. Let's do a L'Hopital rule question. All right, this limit is going to the integral from 2 to 2 of g of t dt. I know that's 0, okay, because it's the integral from 2 to 2. So that's going to 0 over 2 minus 2. That's 0 over 0. I need to use L'Hopital's rule. So that limit is equal to the limit as x goes towards 2 of the integral here. Its derivative is g of x. Divide by the derivative of x minus 2 is 1. We said g of 2 is 5 and g is continuous. Therefore, the limit of g as x approaches 2 is also 5. And so this is going to 5 over 1. All right. Oh, and then the last one. This is a good problem. G is increasing. Well, I'm going to need to take the derivative of g. G prime of x equals f of x. So g is increasing when f is positive. So that's when x is less than 4. Also when x is bigger than 6. G is decreasing when g prime, which is f, is negative. That's happening down here. That's from 4 to 6. Okay, g is concave up when g prime, which is f, is increasing. So that would be from 1 to 3. Also from 5 to 8. And I'm just pointing out you can use interval notation or inequalities, whatever you want. Okay, g is concave down when g prime, which is f, is decreasing. So that would be 0 to 1. Also 3 to 5. Okay, g has relative extrema at places where g prime changes signs, right? So where f changes signs, and that's x equals 4 and x equals 6. Okay, g has points of inflection at extrema of g prime, or places where g double prime changes signs. And g double prime of x is f prime of x. You can say where f prime of x changes signs, and that would be here at 1, there at 3, and there at 5. And that's all I've got for you.